Hey everyone, I'm Declan Fortune, and I was the group reporter for the Clapeyron experiment. Just some background information. The Clapeyron equation, or the purpose and background for this experiment, was to use the Clapeyron equation to determine the latent heat of vaporization during a phase change over a set time of temperatures and pressures. So on the left-hand side, you can see the Clapeyron equation, and then some of the parameters that we used are the saturation pressure, saturation temperature, latent heat of vaporization, specific volume, and the gas constant. So for our apparatus, this is just a simple depiction of it from our lab manual, but you have a 1,000 milliliter flask with a rubber stopper on top to make sure that there's no pressure leakage. We have a hot plate that's used to heat up the water in the flask during the experiment. And then we have an analog pressure transducer at number 4. And at number 5, we have our pressure gauge system and air bleed valve. And the rest of the components are a vacuum control valve, centrifugal pump, water reservoir, and the computer DAC to record all of our information that we'll use for the analysis. Now for safety, we all want to be like Richard, right? So we need our proper PPE in check, which is pretty simple. You just want eye protection, pants, closed-toed shoes, and if you need, heat-resistant gloves. And you also want to follow all the set procedures and guidelines that are in the lab manual. Before I go into the data section, I did have data sent to us because Philip did burn our pressure line. No. I'm joking. It was actually me. But so that data was sent to us, and so that's what I analyzed. So part of procedure 1, we wanted to compare our experimental data to our steam table data. And as you can see, they're relatively close in terms of trend line. However, especially going from 50 degrees to 75 degrees Celsius, it is just a little bit higher. And after that, up into about 98 degrees, they follow very closely, but it's just still a little bit higher. And this is comparing the pressure to the temperature. For the main part, procedure 1, the latent heat was found, which is on the y-axis, through taking the local derivative and graphing it against the measured temperature. And using this local derivative was not an accurate way, or is not the best accurate way of analyzing the data. As you can see, there's a lot of standard deviation between most of these values, which centers around the 0 axis, whereas our actual steam table values is about at 2200. And I used a gas constant of 0.4615 kilojoules per kilogram multiplied by Kelvin, and that's kind of how I solved for the local derivative, doing P2 minus P1 over T2 minus T1. So for procedure 2, the process that we did was done in order to have more accurate data, and I'll go into why it looks a little bit weird in a second. But the derivative was found from our last procedure with pressure versus temperature. So I used the slope to solve for the y and p value, as you can see on the top left here. And then the latent heat of vaporization was calculated with the Clapeyron equation again, using these new values. So using that in Excel with the bottom equation right there, we got weird looking data. As you will see the original one, that I had to add a secondary axis in order to more better view the trend line of the data itself. So you can see our experimental data is not as streamlined excuse me, or linear as our theoretical steam table data. This is what it originally looks like. I believe there was something wrong in my calculations. I spent a lot of time trying to figure out if maybe my units were wrong, but even multiplying by different magnitudes of like 100 or 1,000, the closest I would get was about 800, which was still off, and those units didn't really make sense. So this is what I kept it as here. And so for procedure 3, regression analysis was used in Excel in order to determine more accurate data. Whether or not it's accurate is up to evaluation, but regression analysis was used in addition to, I have in an appendix how I manipulated the Clapeyron equation in order to determine these values. But my A and B values using the Excel's toolpack function gave me an A value of 2,117 and a B value of 37.58. And using those helped me determine the latent heat of vaporization for our experimental values, which is very different from procedure 2. Although we are getting higher values, they are nowhere near what the theoretical steam tables are. So I think that further shows that there was an error in some of my calculations or in my unit conversions. And then before I get to the conclusion, this was some of the mathematical approximations that I made with changing the latent heat of vaporization. So I won't go too far into it, but this is how I manipulated it in order to find my constants and ultimately solve for our A and B values. So that's my conclusion, and if you have any questions.